So it's nice to see everybody. Thank you everybody for being here. We thank you, Dr. Jimenez, for those insights. And we we have a very diverse panel here of industry participants along with Dr. Jimenez to give us perspective on use cases. So there were some questions about whether it's medical, healthcare, other examples of applications. We're going to be talking about some of those things. But before we get into that, it just struck me like all the convergence of the things that we've been talking about, right? They all came together as you started looking at the use cases for digital twin, whether it was AI or ML and cloud computing. These things are, you need all of those things, right? They're all ingredients and elements, security, to give Amir some credit here on the cyber side. But the point is, like, these things are all required to make these use cases happen and come to life. And so, and I was also thinking about, I was reading yesterday that Keanu Reeves was in Austin playing a guitar. If you guys know Keanu Reeves, of course, from The Matrix, right? And so he's in Austin right now. And I thought, I'm so grateful that Andreas didn't like Trump me and get Keanu to do this panel, because it feels like this is literally what he was doing, the story he was telling. And, we'll see where that goes. But anyway, I want to start with, of course, we already know Dr. Jimenez, and thank you for your presentation. I thought what would make sense is if we could just, walk through the panel here. We'll start with George, working from left to right. So George, can you introduce yourself? Tell us about a little bit about your background and then your company.
Sure.
Thank you.
Good afternoon, everybody. My name is George Reed. I'm Senior Vice President of Sales and Marketing for a company called Siradel. Siradel is a 30-year-old company. We're focused we have three pillars of focus, if you will. Company started doing 2D, 3D map creation. So, the Google Maps, which everybody's familiar with today, we've been doing for approximately 30 years. We do it at all different kinds of resolution and quality, depending on the need and the application. As well, we develop tools for wireless propagation and planning. So we do a lot of channel modeling, coverage analysis, interference analysis, all those things that go along with starting way back then, 2G, 3G, 4G, 5G, and we're doing 6G modeling now. And then about a decade ago, we took those foundational skills of map creation and simulation and started focusing on the smart city sector. And so we have a big data platform, if you will, where we aggregate, cross-correlate, visualize all kinds of data on 3D digital twins, either using our own geodata or building data, and then also working with third parties to do that. We have a real-time interface, so we can collect the data that's so important that we talked about a lot today. And what I call going from a static digital twin to a living digital twin. And then we also have a number of simulation engines to do a lot of simulation work on top of that digital twin and those visualization and communication capabilities.
Thank you, George. David?
I'm David Morgareidge, the Director of Predictive Analytics with Jacobs. I've been doing simulation, which forms the core of all digital twin work, for about 4 decades. So I've done it in the physical environment, looking at energy analysis in buildings. And the last 15 years, I've focused on work process optimization, where you build a physical representation of all of the elements that contribute to the success of a work process, and then use simulation tools to analyze and optimize those. I've done 62 of those kinds of studies, written standards for the Department of Defense, done consulting for the UK's Ministry of Defense on their digital twin strategy. Jacobs is an American international technical services firm, headquartered in Dallas, operates in 40 countries, 400 offices, 15 billion in revenue, traded on the New York Stock Exchange. And it's undergone a tremendous transition into a digital services firm from a traditional project-based technical services organization to one that generates 20% of its revenue from digital platform solutions as opposed to projects.
Yeah, that's great. And there's a lot more to unpack. He has a
There is.
lot of experience, so we're gonna get to that. Thank you. So Roger Skidmore.
Sure. My name is Roger Skidmore. I'm the CEO and co-founder of a company called EDX Technologies. Apologies for any confusion. It probably says EDX Wireless on a lot of things here. EDX Wireless was the original company that we spun out of. I'm basically moving faster than my LinkedIn account can keep up, I suppose. So EDX Technologies basically grew out of the concept that essentially everything is related. Everything, if you're looking at a smart city type instantiation, it's hard to establish just one focused digital twin without a recognition that you're probably excluding a lot of other content that could be actually relevant or could be participating as part of what you're trying to simulate or do as part of that instantiation. So what EDX Tech has basically evolved into is we host a global 3D digital representation of the entire planet. We then expose that as a platform as a service for any industry, government entities, individuals, organizations, you name it, to be able to interface through APIs or direct UI UX to interface that platform with their content, whatever that content happens to be. It could be fixed infrastructure, it could be mobile content, it could be IoT sensor data, you name it, streaming video, whatever content is relevant to your organization, either from an infrastructure or asset perspective or from an operational perspective. We have the ability of combining that into a live, persistent representation of that content alongside any other users that are potentially sharing that same space. So anyone that's participating in any way, shape, or form within, for example, the city of Austin has the opportunity of intermingling or sharing content with each other or licensing content to each other within the context of that platform, basically being able to establish a live, living, at the speed of latency, digital twin of any activity within that physical space. And then by hosting everything through a readily accessible on-demand platform, it really streamlines the whole process of establishing what you would call a smart city or even a focused digital twin within that context. So that's what we do.
Very interesting. It's not, I'm sure not a surprise that it's a different business model. It's a different way of thinking about digital twin, which is really interesting. So thank you. Joel.
Joel Warner. I work at Samsung Austin Semiconductor, but before that, I'm an industrial engineer and alumni of Texas State, and Dr. Jimenez actually was my teacher. So, yeah. So I have a lot to thank him for.
It goes back to that.
We don't see any gray hair. I mean, it's very, very small.
Yeah, I'm just that young. Yeah. So, oh yeah. Sorry, I'm actually in the innovation department and hardware innovation specifically. So anything that's physically that needs to be updated, changed, we're doing that. Specifically around making the manufacturing equipment safer, produce faster, produce higher quality products. And part of our workflow is obviously creating a new product or a new part. We're creating a digital part of that. And so in order to make sure that that part will work seamlessly in the equipment, we build the rest of it. And so we got to a certain point where we're basically creating the entire chamber. Why don't we go ahead and create a digital twin of the chamber? And that led into finding out there's a lot of hidden gold going on in manufacturing. One and a couple of things we do is create different models to run, and as we upgrade those models, we create more and more hardware that produce a better and better outcome for our products.
Yeah.
So I'll get more into detail later.
Yeah, that's great. And, obviously, this is happening so fast. I mean, bringing fresh perspective. I mean, having gray hair is not always a great thing. It's a good thing, but it's like we all need to be working together. And I was mostly commenting on that you don't have very much, which is, interesting that you have students already. Why don't we start with the most important question, which is, can you tell us an example of a business outcome that one of your customers has had using digital twin technology? And if you can be specific around the use case, the industry, so we can kind of understand that. And you may have more than one, and that's great. Let's use one now, and then we can come around the circle and talk about. So why don't we go with Roger? Why don't we talk about what you've been able to unlock so far with this new business?
Well, along the way, EDX Tech's done everything from Smithsonian exhibits to nationwide telecommunication infrastructure hosting, performance modeling for wireless telecommunication purposes. But probably the one I'd like to, because I mentioned what we do as a platform and as a smart city perspective, is to talk about what we're doing actually right now today for the northwestern part of the United States. So we're actually launching what's called the Seattle Northwest Digital Twin, which is essentially a proactive representation of 3D Seattle and all the surrounding environments, and gradually growing to be the entire state of Washington. Literally in 2 weeks, we have stood up a high resolution, basically 2 centimeter grade representation of the entire area. It's been connected to the digital twin that the Port of Seattle has been independently developing, so that their digital twin is basically being embedded within our digital twin. So as you zoom down into the port, you essentially transition into their digital twin, or you can zoom out and then have at a macro level, IO from their digital twin is affecting the larger city area. Expanding that into SeaTac Airport, tracking commerce worldwide, so looking at freight coming in, freight going out, and then tying that even further to things like public safety. So we have engagements where we're tracking video camera feeds throughout the whole area of Seattle, and then using that as an analysis for crime and being able to help first responders respond more effectively to that. So that's just a simple example of how this type of framework, this structure, can actually, as a common framework, enable a wide variety of different use cases and entities to be able to draw value from what's essentially a digital representation of what's going on in the real world.
Yeah, that's great. And so that's a great example of the systems view on the pillar of your slide, right, Doctor? And almost a system of systems or interdependency between systems. We're kind of just proliferating, the application of them. So that's great. Thank you very much. David.
One of the key things about making a digital twin work is deep domain knowledge about whatever it is that you're trying to simulate. And as Jacobs has transitioned from an organization that does projects and uses provides technical services to one that develops digital twin platforms and solutions, we've tried to focus on those areas where we felt we had that deep domain expertise to make sure that digital twin was really going to work well. So water is one where we've spent a lot of effort. We're ranked globally #1 in sewer and waste and #2 in water. We've got 9,000 professionals that design those kinds of treatment plants. And the important and interesting part is that we've got 3,000 folks who operate 200 treatment plants. So we've got a full life cycle perspective on what it takes to make treatment plants successful. When we've added our digital twin capability on top of that domain expertise, we've had really good results. We've done projects all over the world. One good example is the Agua Nueve water reclamation project in Pima County, Arizona. We built the facility, we designed it, we built it, we operate it, and the digital twin was able to reduce the energy consumption by 20% by better optimizing the set points for blowers. If you're interested in how your organization can move from wherever you are on the continuum to getting a full-blown digital twin, the St. Louis Sewer District is a good example. They had about 75 miles of combined sewer outflow systems that had overflows during wet weather, and so we were hired to develop a project to try to mitigate those. And we built a digital twin and a 3-year program that took them from no digital infrastructure to a full digital twin. And I think the important part there is going from nowhere to a digital twin doesn't happen overnight. And we've several times used a 3-phased approach to get them there. And that first phase is the simulation model that I mentioned earlier on. It's the heart of kind of all digital twin projects. And the good thing about those simulation models is they often provide value right up front very early that helps support the rest of the journey to a full digital twin. So in the case of this St. Louis project, the digital twin alone, the simulation model alone, was able to reduce those overflows by 20% or 47 million gallons per year. The digital twin is currently in development. We're using Microsoft's Azure platform. It'll go live in 4 months in January. And so even though that's not I can't report on the results of the digital twin itself, I think to me, the important thing is that embodies a process that we've used in several markets. I've done one in healthcare that worked that same way. That start with a simulation model, the client gets direct benefit from that, and then gradually you layer on the digital tools to get to a full simulation model.
Great. Yeah, thank you. I mean, it's just the progression, right? It's the progression of the
progression.
technology, and it's the progression of your clients and how they adopt it is what I'm hearing. And so that's practical, right?
Yep.
A good way to get there. George?
Yeah, I'd like to present an example it's called the Île-de-France region. It's the Greater Paris region. And this is a digital twin that encompasses 5,000 square miles of territory. So we built the digital twin by starting with the geodata. We've layered in over 10,000 data sets of information that's been provided by the municipalities in that area. There's also third-party data sets that we layer in. We've done a number of public-facing services. So we worked on it's an open website that anybody can go to and look at the information or the services that have been developed per the customer's requirements. Some of them are just simple visualizations of where things are, but we've also done a number of simulations for them. We've done some flooding analysis. There's a big river that goes through the area. So we've done flooding analysis. We've done simulations, what we call multi-infrastructure simulations, where we do a simulation of an optimization on certain aspects, and they're looking to deploy security cameras, lighting solutions, and then some level of interconnectivity, so wireless interconnectivity. So we took all those inputs. We had poll candidates for all of these. So we optimized based on KPIs set up per minimizing essentially the costs across the footprint of the security cameras, the costs with the replacing the sodium light bulbs with LEDs. And then we looked at the wireless footprint and wireless connectivity across all those elements. And then also that whole region, of course, is home to some big sporting events like the rugby championship and the Olympics. So we worked with some other companies in doing crowd management simulations. So, and this entails having live feeds from cameras. It also looks at where are the routes of ingress and egress. So really the goal is to look at things from the perspective of if there's an incident where you have to move people quickly, how do you get them away from the incident? So we've run a number of simulations in that area for those kind of crowd management things. And then lastly, we've done a number of mobility simulations where we're looking at traffic corridors, and we're looking at different simulations for what happens if what happens and cross-correlating data. What happens if I increase my EV rate in terms of my either increase in pollution or decrease in pollution vectors. So those kinds of things where we're looking at transportation, not just from a mobility perspective and looking at route design and those kinds of things, but also the corresponding data that you see when we look at those kinds of things from a decarbonization perspective.
Super helpful. And I think there's a lot more to unpack there. So we're going to come back to some of that. Okay. Joel, can you share a little bit more about the specific example at Samsung?
For sure. And I'll actually share another one, an environmental one,
Okay.
a private one.
Great.
But a good digital twin. I actually have a paper on this, so it's all open information. I can
Very
share on
generous.
you.
Thank you.
Yeah.
Yep.
So we created a digital twin of electroplating process, and which is really cool. And in that digital twin model, we found incongruency in some flow patterns. And so we went more and more simulation and changed different things, and then actually started routing things back into the real world. I guess I think we call it twinning. We go back and we identified a couple of items that needed to be updated. Ended up creating new IP, changing the way it's designed, increased edge yield by 2.2%, which people at work jump on the table and clap their hands on that one. What that really means is millions and millions and millions of dollars every year, and probably a couple of $1 million every month, increased profitability. Also, our customers are incredibly happy with that, because if you can prove that you're doing fundamental changes on the manufacturing equipment to get them the yield on time and when they need it, it makes a big impact on who they choose to manufacture the products.
Yeah.
But yeah, we're doing that across the board. It's very exciting stuff, and it's all right there. Things that we can just model, put in twin, pretty cool stuff.
So what I just heard is
Yeah.
we've got IP, we've got, he's got this paper. I mean, this is your new future, assistant professor,
Yeah.
PhD candidate, right?
Yeah, of course.
So, no, that's fantastic. And so,
I was going to share one more.
okay, go
that's
ahead, please.
interesting,
Yeah, go ahead.
especially with Jimenez.
Please.
And we, Andreas and I have been talking about this too. So a private team here in San Marcos launched a smart paddleboard. And what that does is it actually creates a digital twin of the river. And in order to get the lowest cost for recovery of that data, there's a smart off-grid kiosk. So the general public can rent it, very low cost, go and paddle. So all the labor free to capture all of the data on the river. So we've done an entire year worth of data collection. So it is pretty cool stuff, seeing just incremental temperature and conductivity. And so what that really means is pollution happening? Where is it happening? And is the remediation things we're doing working?
Yeah.
So, and free.
Are we talking about the
Guadalupe
Guadalupe or which river?
We're launching in San Marcos. Actually,
Okay,
if you go
great,
to 111 MLK Drive, you can see the kiosk.
Okay,
right there.
very
So,
cool. Yeah. Yeah, the business model is genius. I'm here. Yes. Yeah. Right. So integrating fun with data and having the humans be the rabbits. Is that what you're saying? Right. Yes. Right. Yeah, it is. And I think that's really part of what we want to make sure everybody's getting right now, is that the business models, we haven't even scratched the surface on what's possible. Right. So thank you for sharing that. That's great. Okay. So I want to come back to some of the examples that you were talking about, George. So you specifically were talking about crowd control, mobility, and what was the other one? In Paris or in the greater?
We've done flooding.
Yeah,
crowd
flooding.
control.
Yeah. So when you think about like, you were mentioning lighting, and different applications. So at CMG, of course, we're always trying to help clients make choices about technologies that they can consider adopting. And what I'm hearing is that digital twin technologies are a way to basically model out, de-risk that thinking. There's lots of ways to get some evidence, right, and feel more confident that these are strategies that are worth investing in. Can you talk a little bit about what are some of the insights that your client was able to glean from the work with the digital twin, and then how has that helped you across your business to explain this to other clients that they can harvest the same value?
Yeah, so it's a good question. When we work with our clients, it's always you start with a workshop. What do you want to do? What do you want to accomplish? What are your goals? At the highest level, every city that we go to, and I'll make a qualification here. I say city, but it's really a general term for smart entities. Ports have been mentioned. Ports, airports, territories, regions, counties, manufacturing environments. So anything we look at it from a macro scale. We're not down at the micro scale per se. But so we work with them to ascertain what their goals and objectives are. And then generally there's a long list of KPIs that we develop together.
Mm-hmm.
We already have deep knowledge on many subjects. So we start with those and then we go beyond that. So we look at the KPIs and then we will run some simulations using their data plus third-party data as necessary to look at a bunch of scenarios and of course, a bunch of outcomes and measurements based on those KPIs. So you take all that information and then you say, well, let's make some prioritizations. Let's make some decisions on what the best course of actions are. And I'll give you just one other example. We're doing a lot of work in the climate space. The EPA has allocated $5 billion for climate pollution reduction grants, and they've already sent out $50 million to regions to help them develop the first level plans, and then the rest of that, or it's 250 million, I think, but the rest of that money will then be used on very detailed climate action plans. So there again, it's a whole series of how do you guide people through this process, develop information that's necessary and needed to develop the best plan going forward. And the best part about what I like about when we talk about regional digital twins is the fact that climate doesn't stop at the city border, neither does a traffic problem, neither do many other problems. So the fact that you're looking at things regionally is a much better way to look at it. But obviously we're all aware of climate issues, the terrible heat that's been happening. And so now you take all that information, you mash it together in a digital twin, you visualize it, and then you're able to derive actionable data, actionable conclusions, and make some intelligent decisions about how to allocate precious resources and funds.
Yeah, great, thank you. Same question to you, David. How do you help, or how have you seen clients? You mentioned a few examples in water and sewer. How does that help people take action?
It's the only way you can take intelligent action. There is no other option.
Yeah.
There's no other design strategy that does what a simulation or a digital twin does. In the design, renovation, process improvement stage, we call it a simulation because it doesn't have direct feedback loops. But I've done simulations where I looked at 9,005 different solutions for an Army issue. And the confidence that gives to the client is just off the charts. When you're making a couple of $100 million investment in something, if you can say, well, here are the KPIs that are important to me, here's all 8 of them, and you run simulations and you rank order the results based on their ability to achieve those KPIs, suddenly what seemed like a rough decision to make is not rough anymore. You can say, well, and those simulation models or digital twins, if they're built right, are 100% faithful representations of the real world. And so you're not asking somebody to go forward based on, floor plans or something sketchy. It's actually an operational model that shows what's the profit level going to be, what's the cost per this, the cost per unit that. So you actually can line up the future state to match the pro forma that they have that supports their investment. I mean, there's no other way to make intelligent decisions anymore.
Yeah. No, I think we're empowered, right? It's a different way of making those choices instead of it just being that design itself. It's actually let's simulate that. That's helpful. Thank you. Let's talk a little about the tools. So there's a couple of things. There's a perspective around, we have a consulting engagement, and then there's software that you were using. Can we just get a sense of just tell us a little bit about, how do you do this stuff? Who wants to take that? Professor, can you get us started? You're using something.
How to develop the digital twin? Well, there's a lot of opportunities in that area, and a lot of the development that I have seen, they start from scratch and integrating different tools together. More conventional applications like simulation modeling tools, specifically discrete events, they are opening up their software so that they can do the digital twin integration, meaning collecting the data real time and producing the real time solutions. And a lot of times what they're doing is they are embedding into their system some artificial intelligence modules so that they can interact with your model. So there's a lot of opportunity for tool development in that space, and it's one of the areas that will grow significantly.
Yeah, would you please? Yeah, go, yeah.
Yeah, so since my background is in those simulation tools, to me, the evolution of those tools into the digital twin world has been sort of the focus of my whole career. And what's interesting is these design tools, and there's probably 6 or 7 in the discrete event simulation world that are commercial good solid products. They used to be used for design, and now when you connect real-time data feeds and add AI and ML overlays, suddenly those same tools are not being used by the designers. They're being used by the owners. It's a complete paradigm shift where this tool that used to be something that a design firm would use to get you a one-shot solution, now that the client owns that software and they've got real-time data feeds going into that tool. They've got connections through Azure or AWS or Palantir or whatever they're using. And it's an interesting impact on the design profession because it shifts the center of gravity away from the one-shot design fee to something that's now owned by the client.
And recurring in a way, or at least
yes.
alive, right? It's evolving. I mean, and as things shift, you can make choices. And it reminds me a lot of like what's happening with AI too. Looking for other panelists that were in here, but the fact that MLs and ensembles are being created and people are thinking about what are the business models around those, right? And can you share those, or what does that look like? So it's not just like you hire a firm and you buy a tool and then you design the thing, right? Like we're way past that. And so if you're not thinking about things that way, I think this is an opportunity to kind of have this panel and this day's content trigger that.
But just one follow-on thought. It's in the architecture, engineering, construction world, which is where I've spent my life. The impact of this is absolutely phenomenal.
Yeah,
and you can see what it's done to Jacobs, because as Jacobs has realized what that means, they've shifted their entire business model away from projects to developing their own platforms, and we now have 11 digital solution platforms. So we're a digital firm, not. And that sort of transition is one that's happening across a lot of industries as they realize that the old model is being totally upended by this technology.
Yeah, great. Okay, George, then we'll come over here.
Yeah, and I'd just like to add that, the question before was where do you get started? How do you get this started? From a digital twin for a city, it's simple. I mean, you can pull up a Bing map, you can pull up our map, and you just import shapefile, GeoJSON files, anything that has a geospatial tag, or it's a spreadsheet with a latitude and longitude. It's that simple. And that's where you start. And you can start instantaneously. And it's just a matter of, at the city level, the data that they have. I was speaking earlier with other folks here. There's also a cultural aspect to this that we all need to address as we go forward. I think everybody here is very techie, but I heard it from, was it Ted Lair?
Yeah, I think so. Yeah.
Who came out of Austin, city of Austin?
Yes.
Yeah. So he hit the nail on the head there. He said, we can bring all this great technology, but how do we convince the people to use it? So one of the great aspects that I see at the city level is the visualization of all this data. So if you bring a cool 3D map to somebody, they go, "Oh yeah, that's pretty cool," versus a spreadsheet or a dashboard that just has a pie chart on it or something.
Yeah.
So it's not just us convincing us that this is great.
Yeah.
Which it is, because I'm excited about it. Everybody else here is excited about it. But when it comes to there's the political angle, there's the economic angle, there's the cultural angle, and those all have to be considered in terms of making all the hard work that we do at the technology or technical level to come to fruition. Because if you're not looking at the cultural aspects, the economic aspects, and encompassing your constituents, which we're not the only consumers of what we produce, particularly when, again, I focus on the smart city level. You really need to take into account those aspects, and being able to communicate things visually in a beautiful way. And you showed some great video. I mean, all of a sudden that video is a great communication tool that helps convince people that otherwise might not be convinced that what we're developing collectively are good things to deploy.
Yeah, that's great. I think so what you're saying is we don't need to wait to do a digital twin project until we get a massive bond passed that gives us a bunch of money to go build a dam or something. Is that what you're saying? Okay, good. And I agree, right? I mean, I think we all agree. So, Roger, you had a comment.
Yeah, let me take this for a little bit direction. I'll nod and say, yes, I agree with everything that's been said up till now. From an engineering point of view, there's never been a point in time in history that's been easier to collect data. Data is piling up in mountains waiting to be processed. The issue is that a lot of times the data is segregated in a way where it's hard to cross-correlate it because it's been optimized from a collection and a visualization and a processing point of view in very specific silos within organizations because they know how to process this type of data. But in reality today, again, everything's back to being interrelated. So at the atomic level, if you can bring things down to, every piece of information has a position or a location and a time. And then you can begin correlating that information together inside of a framework. If you approach it from that point of view, whether you're looking at a frame out of a streaming video feed, or you're looking at a set of IoT sensor data that's coming in, or AVL tracking system, or what's the current state of the construction project that's ongoing, if you can organize it from that point of view, from a fundamental point of view, you basically have established the framework for doing any higher level analysis, because the data, no matter where it came from, what its format is, how it's structured at the atomic level, shares characteristics that you can begin correlating in time and space. So with a slider bar that says I can go back in time, basically rewind the clock, what was the state of everything at the time the event happened? What can I learn from that by being able to rewind the clock and see what happened that led up to this point in time that had this event happen? And what can I, as an individual or a team, gain from that? At the same time as being able to say, if I insert information into the future, I'm planning on building, this set of EV charging stations across the city. Each one of those will have a timestamp associated with them in the future. Can I move that slider bar into the future and see what's going on at various points in time, which can help other entities from a planning point of view to know, oh, there's going to be an EV charging station there. I didn't know that. That fundamentally seems very simple, but it is. There's a lot of value there, just being able to exchange information and present it in that fashion. And then by having exposure at the API level to where AI, machine learning, and other processes can begin tapping that knowledge that's been organized and structured, there's a whole new, generation of being able to process, handle this quantity of information and new ways that we're going to learn from this in terms of being able to improve processes, gain new efficiencies, et cetera.
Yeah, that's, really getting a structured way to think about all these elements is what I'm hearing. And then, of course, we have to make sure that as I'll say democratize the data, although some of this stuff is proprietary, but let's just say it's more exposed. There's all kinds of questions and risks. So Professor, maybe you can talk about, help us kind of synthesize what are some of the things we should be thinking about as we're exposing all this stuff, right? To some of this is opening up, becoming more available. There's a commercial model around it, but some of it is also you're plugging into some projects, right? Like the SeaTac airport and the port. And so I just have questions about, how safe is this and what should we, because this could get scary too. It's really exciting and there's some questions. What do you think about that?
First of all, I just wanted to talk about
Okay.
what you mentioned on the technology to attract people.
Yeah.
I think that is a key element. And how do we get people interested in deploying these technologies and animation, visualization, and also the use of technologies like VR, AR is, getting not only the managers or the adopters to gain interest, but also there's all this pipeline of developers that also need to get interested in the field, and we have seen those technologies are very useful. And then other aspects that are important to think about is those business models, the data sets. How do we get access to the data sets so that we can train these machine learning tools? And then that point in the conversation I made earlier about the collaboration and how do we take advantage of the digital twin and make it an asset so that we can share it with other parties,
Right.
and enable that collaboration, but also enable entities to make generate some revenue from the digital twin. I think those are interesting ideas that we should start discussing so that we have some opportunities to further develop this technology.
Digital twin is a service with a set of twins that you can rent and then make that a business model.
Right.
Yeah. And then, which is good. And then I guess, and you're probably thinking about this because this is tied to your business model. How do people get comfortable that they can use it, plug into it? Like, what are some of the things that you've seen so far in this journey you're on with your company to make it, both available and safe?
We don't have time for all of that.
Okay.
There's a whole other panel session about the moral and human nature aspects of digital twins as it relates to smart city and content. I would say that the things that on a technical side, purely technical, I typically get asked, are you CPU limited or are you GPU limited? And the answer is I'm IO limited. It's the ability to collect data at a really fast rate, low latency. That's more at the quantities I need. That's more of an issue than being able to process it or render it down. But the whole other basket of issues that we're encountering regularly now are more about data security. If you want to, bring down the wrath of God on you, start getting into a room with federal officials and start talking about cybersecurity as it relates to smart city initiatives. Critical city data winds up being national security information when you start talking about electrical grid, utility information, flow of commerce through ports. That's a topic. And then that slams right up against data privacy. Increasingly, a computerized system can tell anything and everything they want to know about you remotely. So how does that relate to content at the city level? Simple example with the city of Seattle, they wanted to instantiate what's called, some people may be familiar with, it's called shot collar. It basically is a system that uses sound waves to figure out where a firearm has gone off. So it can triangulate locations of basically gunfire automatically. And then they wanted to be able to display that readily for any of the public to be able to see it. The idea being that from a public safety point of view, maybe you want to get an alert that says there's a gunshot close to where you are.
Yeah.
The flip side of that is that when you start aggregating that content, people start deciding that it affects their real estate values. So there's a human nature aspect to this that winds up being lawsuits against the city, and you're engaging my privacy and you're affecting my real estate values by posting this data. It's not that the data is not there. You're suddenly entering into a phase where it's just instantaneously accessible and readily viewable by anyone, any location, anytime. And so that brings in insurance conversations, that brings in, government regulations, and, are you invading my privacy with this data? Those are all things that's a whole other ball of wax when you start talking about smart city digital twins and the things that they bring to the table. Yeah.
So Professor, this is like why it's so interdisciplinary, right? Because it's just such a big thing. This is just not a technology problem or opportunity. It's so, I think, the reality is that we have to understand those things, but at the same time, kind of the truth sets us free. Things are happening, right? Data is flowing, people are moving, and there's innovation happening. We need to figure out how to do it and do it well. So
one thing, I should have also mentioned, the same conversation with the cybersecurity people in terms of securing smart city content, the total opposite flip side of the conversation is, how easy is it for an organization like FEMA to come into an area where a hurricane has come through and tap into smart city information that's there relevant to them to respond to that much more efficiently and quickly. So, it's always a push and pull in terms of what you're able to deliver versus what people are willing to accept versus what maybe is in the best interest of the overall public in terms of being able to utilize this information.
Yeah. Great. Did you have something else to add?
No.
You're good? Okay, good.
I have a quick comment
Please,
there.
Go ahead.
One of the more popular concepts that's come up recently is called a 15-minute city. Everybody know what that is?
Why don't you share, please?
So it's really the ability to show, visualize on a map. You pick a point in the city, and within 15 minutes walking distance, can I find a hospital, a grocery store, entertainment venue, automobile dealer, EV charging station? So really, it's focused around economic development and an attractivity aspect of a region in a city that says, hey, I want to bring these people into my area. How can I do that? Well, I can show them that all of these assets or these needs or wants are within a 15-minute walking distance. So when you look at downtown revitalization,
Yeah,
that's the kind of information you want to collect, you want to display as a city and say, hey, I have all this stuff. I have, or schools are important, that kind of thing. Schools, hospitals. So,
yeah.
So it's a popular concept. Well, I was talking to a lady from the city of Calgary in Canada. She said, don't talk about 15-minute cities because the view there is all of a sudden now Big Brother is watching me. Now they know I live in this 15-minute area. Now they can get more information on me personally, and they object to the fact that somebody can know that if their information is available in the context of this area,
Yeah.
all of a sudden now I'm being tracked or somebody's
Yeah.
watching what I'm doing or following me. Well, okay, yeah. So you got a GPS on your phone, you know.
Yeah, I mean, we all know the Toronto, project and what happened and all the, PR that happened as a result of that. So that maybe that just needs to wash out, like a lot of narratives, right?
Yes.
Because people get, fearful about certain things like that. But on the other side, like if you go to Zillow or Redfin or one of these, applications, I'm almost certain I've seen that attractiveness dimension on like my house. Like if I go look at Zillow for my house, it says I live on the west side of Austin and I don't have public transportation. I get a lower score.
Yep.
Have other things that are positive, but I'm just too far from public transportation. So those things are important to know, right? And they're scoreable, right? They're very easy to score. Great. We talked about data. And so I'd like us to just talk a little bit about the access to data. Like, what are let's just get some examples of data kind of on the table so we can feel the breadth and the aperture of that. And also talk about the data access and the data quality challenges, and strengths. There may be some certain sources of quality that you're like, look, this is, Roger or others with your clients. These are strong data sources that are reliable, high quality. These other attributes are a little harder to get, or they're a little harder to enrich with human in the loop and other strategies to make them work. So can we talk about that? Maybe, anybody that has an opinion on that, let's just get rolling.
I could talk about that for an hour.
I figured
so
that's why I started with you. We get you going and then we'll get everyone else to come in. Thank you for being my foil on that one. Go ahead.
Okay, so EDX Tech's official point of view is every piece of information, regardless of its format or where it came from, is useful to somebody at some point in time to do something with. So the more data you can collect, the more data you can organize, the more you can put it in the context with other data, the more you're able to potentially solve problems and issues as they evolve. So that means that I deal with just about every type of file format that's out there at some point in time. The more common types of data, buckets of data from a smart city point of view that we deal with. First and foremost, like George mentioned, geographic information about the environment. It's interesting even just to focus on that in terms of the different perceptions of the customer in terms of the way you present that information to them. So engineering grade content that you can design a wireless communication point-to-point link and make sure that you have enough clearance over the rooftop for that signal to make it maybe an entirely different model from one that looks really nice and pretty and actually looks like the city when you actually are engaging with, real estate or architecture.
Yeah.
This is still the city, but the origin of those data sets may have a radically different application in terms of what you want to use the data for.
Yeah, and certain applications or use cases like must have quality, right?
Yeah,
like
exactly.
When we're talking about fire department, they have to know. And then you got other ones that are like, hey, I'd like to know where I'm going for, my dinner.
Interestingly enough, it's kind of there's still not really significant easy cheap sources of information that kind of bring the engineering quality data together with the aesthetic quality.
So what you're saying is that there's another business opportunity in digital twin.
Well,
Okay, got it.
So EDX has a global data set. I have to deal with global satellite companies. They re-image the entire planet every day. So your picture of you is captured every day from a satellite somewhere over in orbit continually. That data forms the foundation for global data sets. For regional or localized data sets, then you open up the door to like aerial or drone capture for data. That may be high quality 2 centimeter resolution 3D information about an area, or it could be drone LiDAR capture data content that comes in, and that can complement other types of data sets that you have. And then the processing that's done on that has a very dramatic effect on the aesthetics of how that model looks and feels when people are interacting with it. So there's a huge breadth, even just looking at the geospatial content that forms the baseline for what I do in terms of the quality and usability.
Great, thank you. Joel, what are you seeing? Oh, well, let me come back to you next.
Sure.
Go ahead. Yep.
I don't know if you see my title, and I haven't talked about that at all.
Yes,
but,
right.
that actually has a lot to do with what I'm looking at right now in digital twins. If you have a million sensors, you're going to have some density over some area. And so what happens is your cost per sensor has to be low in order to have that density. But if you have something autonomous like a drone going around, you can actually have really high quality data, but then you can get really nice density of that data. So I think the future of data acquisition is probably going to be high quality sensors on some autonomous platform that's reacting with some low quality sensor data outside of that,
including boards, right, on rivers.
Absolutely.
Like, I mean, I think that's what I'm hearing from you, and that insight is really important.
Yeah, that's our long-term goal is actually for autonomous deployment of autonomy. For interesting things, like for instance, San Antonio, very well dense area. There's dumping happening every week. Talking with the organizations down there, illegal dumping. And then they'll go down there and it's gone, and their sensor down the river say, hey, it's clean now, and they do it on the weekends. So what we want to do is say something's happened, take a sample, do what we need to do to collect that and know where it's coming from.
That's great.
And then with autonomous platforms, I think that's possible.
That's the future of getting that quality data and that frequency. That's great. David, you were going to say something?
Yeah, we work in sort of different levels of data, geospatial. A lot of the work that we do is with clients who are manufacturing, healthcare, pharma, that think they want a digital twin, and they come to us and say that they want this digital twin to help optimize their process, and we say, okay, that's great. So in order to do that, we need to have some historical data that covers all of this stuff. Can we see that? And that's when the wheels fall off. And somehow, the simulation never caught on, I don't think, quite as digital twins has. And people have jumped over simulation where you would, if you wanted to do a simulation model, you'd have to have collected that data. Suddenly they're at the digital twin stage and they say, gee, I want a digital twin. It's like, okay, well, the basics are we need good data about what you do. Do you have that? And I've worked for, confidential clients in the government and healthcare they're at the top of their game, that everybody in this room would know the name of the organization or the firm if I mentioned it. They came to us and wanted a digital twin, and it was back way off. And it was extend the life of the project, and it was implement new systems to track the data. So a lot of industry has caught on to this thing that say that they want this digital twin magic, but but for the last 10 years, nobody's done the homework of keeping up with what they're actually doing. And so there's no historical data set, and there's no electronic data system to gather that stuff. And so sometimes, I've been hired to do work and had to tell the client, we can't do that until we collect data. And they said, all right, well, you give me a fee, give me a price. What do I need to do? And so suddenly the scope of the project balloons. It's twice what it used to be. And it's because we had to collect some information before we could get to a simulation or a digital twin. So I think a lot of the world has to kind of catch up on, you need to do the boring nitty-gritty homework of collecting and managing data if you want to get to a digital twin.
The message is you have to have sensors and data, and there's different ways to get them. And so, go ahead.
An excellent point. I have yet to encounter a public utility that has any real solid idea of where all their assets are. So, if your starting point is I want to have a digital twin of all my assets, and you don't know where all your assets are, there's obviously going to be a service aspect to that in some form or fashion to collect data that's part of the instantiation for that type of content.
Yeah, so if that's you should call us so we can help you get some resources to get perspective on that. Lots of friends that we have that can help you with that. Great. We are about at time. No, we okay? Okay, good. All right. Well, great. We're not at time. So what that means is we can open up for Q&A, but before we do that, I'm just going to ask, we had a few examples shared, but are there any other case study examples that are burning that you just want to make sure you've shared that I haven't given you enough time to share?
So I have one, I mentioned it a little bit before, but we have a great use case, which is an EV charging station location optimization simulation. And that's really hard to say 5 times fast.
There you go.
So what I really like about it is fact, so we get traffic data. We are not a data producer per se, so we have to source this elsewhere, but there's plenty of companies in the business of collecting traffic data, streetlight data, INRIX. So we take that data and then we look at the grid, we look at other components, and we come up with an optimized solution that really does a forecast of if you place the EV charger here, then your utilization rate will be X. And then there's also a financial component, not just the cost to deploy, but then the electricity generation can be charged. So there's a revenue model associated with that. So I think oftentimes we just look at simulations and say it costs this. But if you can couple that with a revenue generation model, then it really becomes cool.
Once again, we get to layer on another way to think about this, right? And create another business model or service. Yes. Amir.
This is more of an observation. Any output of a digital twin, if it's a smart city, if it's a workshop, Industry 4.0, begins to be protected as a master. The trend for Industry 5.0 actually allows the human intervention. That's where you're going to get even more competitive advantage. So what was once Industry 4.0, you can put it out there and sell it as a model.
Yes.
What you have with Industry 5.0 with the human intervention is that you keep forever.
Yeah. Well, so we were talking. So Amir was talking about Industry 4.0 versus 5.0 and human intervention around that, and who has that data and what the business model is. So yeah, I think that's a great way to think about our next year's panel and kind of what happened between 4.0 and 5.0 next year, or how that evolution is going, because it's still happening in its early days. Great observation. Any comments about that? Anybody want to address that comment before we go to the next? Any other examples? Any questions? I know. Yes, please.
I'm not in this industry. What's Industry 4.0 versus 5.0? That's question one. Then I have
Let's address that one first. Who wants to attack that? Professor, can you give us a point of view?
Yeah, the Industry 4.0 includes all these technologies that we're talking about, the digital twin, the big data, 3D printing, robotics. So industry is using those to enable smart decisions within particularly manufacturing sectors and industry sectors. My understanding for Industry 4.0 is the new paradigm shift that you're including the human as a component in terms of their sustainability. The human element, but also you include the sustainability. How do you make the system sustainable and being able to maintain the balance in your environment? So
yeah. More integrated, more inclusive. Yeah. Yes.
There's a lot of knowledge that goes in, and expertise that goes into creating these digital twins. I think most of you have touched about the rental of the digital twin. When you're let's say a city wants to redesign their airport, and the officials say, I wanted to accept a Airbus A380. Do you go to Boeing and you ask them for, do you go to Airbus and ask them for their digital twin of that? Do you rent it out? Does that happen at all or not yet?
Anybody having a point of view or experience with that example or something like that? Maybe on a smaller scale?
Let's say that
Yeah.
There's specialized simulation
Try to get on.
software. There's specialized simulation software that addresses airport design, and they've got all the data about all the airplanes and their takeoffs and landing and how many passengers, deplaning, planing. So that's a great market, and people have started building the tools to address that. So you don't need to go to Airbus or Boeing. There are software firms who've got that.
So like in AI and ML, we're seeing verticalized, hyper-specialized applications with the capabilities and the data to do that best, is what I'm hearing. Does that answer your question? Yeah, good.
Yeah, at a macro scale, the ideal there would be that you could, like Russian dolls, have digital twins dropped into other digital twins, dropped into other digital twins, and the simulation will work out perfectly. And putting on my digital twin consortium hat, that's basically the goal of life, is that you could digital twin everything, and a very precise model of any aspect of what you're looking to analyze as part of a larger system can be plugged into that larger system, and then seamlessly information just magically flows across it. We're a ways away from that, not just in terms of technology, but in terms of data ownership. So, no airplane is designed or built at Boeing now unless the whole thing has been simulated as a full digital twin of every component down to the minutia.
But that digital twin isn't commercially sold or rented.
Right. So then, have fun going to Boeing and say, I want your digital twin of your airplane. Yeah. It's there's a problem with that.
Yeah, it's the same way that, in the military, there's all these different, teams, right? So that nobody actually knows how the whole thing is put together unless you're the top. You were going to make.
I was going to say, as far as like a revenue generation model for sharing digital twin, we develop hardware. And so a lot of the hardware has a lot of components. So we always pick component manufacturers who share their digital twin because it makes our turnaround time really fast. So I can go in and create something in a matter of minutes because most of the components already have a digital twin created. So it's drag and drop and then good to go. So those people get my money.
So the procurement process, if you want to win deals, if you're a vendor selling really anything to someone who's going to rely on this technology, is you need to have that in your proposal. Yeah.
Yeah. So, I can jump on that too, because part of what EDX Tech essentially provides as a platform, the concept of there's one city of Austin, everybody's participating in the city of Austin. You have the ability of putting a price tag on your content and then subscribing access to that content out to other users. So you can create content. If you make a model of a Boeing airplane and your own digital twin of it, you'd be more than willing to share that for a cost with the airport at the city of Austin. The city of Austin could decide if they want that, if that's quality enough for them, does it work for them? It becomes a marketplace for digital twin content essentially for everybody participating in a given area.
All the lawyers on this this staff right now are like, what? And how's that going to work? And it's like, well, wait, if my kid draws an airplane, is that a digital twin? No. Okay. And then there's their design. That is okay. Where in the continuum is right? I can already see that happening. So, well, good. All right. Thank you for that. Yes.
I'm not quite sure how to ask the question, so part of my babbling through this a little. The Formula One example that
was
the
McLaren example.
earlier,
Yeah. Mm-hmm.
A very good data collection on what goes on. I'm a Formula One fan, so
Yeah.
very fascinated with all the telemetry
Yes.
information they're collecting. Being able to do a digital twin of something that's on the track before the race occurs, you got all that, you got all the telemetry information. But after the race starts, there's no analog for what is going on during that. There's no known aspect of safety cars, et cetera. And when they happen, all sorts of things start to become very dynamic. Do you see the digital twin use cases being more applicable in situations that have much more of a rigid, or I'll say semi-rigid repeatability to them, so that you can make some projections as to what's going to happen when you want to apply it to something that is then going to be a bit of a forecast for what's next?
I will try to repeat the question or summarize, and then I'll let the team answer. So the question was, given the example on the keynote earlier from the consortium speaker, Dan Isaac, about McLaren and F1 and the telemetry at a million data elements per second, right? All that stuff. And that you know, because there are exogenous variables, you could say, or random things happen during a race, right? And there's, you know, different kind of yellow flags and different incidents and weather and whatever happens, some of which you can predict and some of which you can't. Is that not the ideal, application of digital twin, because there's these random variables versus other things that are more predictable? Is that, yep. And so who has an opinion on that? I'm also a F1 fan, so I actually have thought about that, but I'm just going to be the moderator right now. So
does anyone know exactly what McLaren is doing in McLaren?
Does anybody on the panel know exactly what McLaren is doing? Okay, Andreas, can you just speak loudly so we can get it on the camera? Thank you.
The answer is they actually run the race and the twins collecting the information.
Yep.
After the race is lost or won, they review the model and they create a new set for the next race. So in the race is a lap.
Yes.
So, you know,
each lap is a race and they collect it for each one, and they're just constantly rethinking.
They're telling the guy you can shift to forward for gears,
yes,
slow down here, and they're dissecting the rate, and they're all doing that at the same time.
Yeah. So they're doing that, and they're able to do that. All the cars are doing, every lap is a race, and they're just constantly using that telemetry and then recasting their strategy, unless they're not Max Verstappen, because they can't be that guy. Sorry. Did I just, was I opinionated? Sorry about that. I'm Dutch. What do you want from me? Yeah. So anyway, all right, good. Thank you. Hopefully that answers
to take it out of that real-time kind of high-speed environment into a little lower response time needed type of situation. We have a partnership with Oracle, and part of that is machine learning for analyzing assets that are on a network of equipment, like a utility. With time and machine learning and AI, they're able to achieve 80% prediction rate within 2 months of when an asset on your network is going to fail. So from that as a milestone, you know, the ability to preemptively replace or do maintenance on a piece of equipment, because the computerized analysis is continually running and identifies this thing's going to blow up within 2 months, has a significant amount of value.
The second part of the question is that's almost perfectly sanitized, repeated data.
Yes.
That gets you to the preemptive.
Yeah, you want a clean room use case, right? Is what you're saying. I want to know exactly what's going to happen so I can hyper optimize that. And life is, you know, butterfly effect, dynamic, whatever, and you know, that like there's those use cases too. But I hear you. Like I think we can learn a lot more. There's more to learn in those really clean examples, and yet there's money to be made in these other ways too. So, great.
I think I forget what the term was that the keynote probably used for forward-looking simulations or
it was FRS forward.
Like that. But I think that's really what digital twins are all about. It's and we've done this in healthcare, where you're training your model against all your historical data. You're looking at external factors, traffic, and you're running thousands of scenarios looking at potential future state issues, and then planning mitigation plans for any one of those that might happen. So that's really the value of the digital twin. It's to not in a simplistic way look against future state scenarios, but model a whole bunch of future state scenarios, look at potential risks, look at mitigation factors, and try to put in place the one that hits most of the bad situations and minimizes their impacts. So whether that's computer-based maintenance things, or whether you're trying to run a hospital and make sure that the wait in the emergency department never gets over 200 minutes for an admitted patient, or whether it's a water treatment plant, or whether it's NASA Langley Labs, where we did an installation where we did that monitoring. I think we put in 128,000 sensors over 42,000 pieces of equipment, and reduced their maintenance costs by $4 million by looking ahead, finding when things would probably fail and replacing it before they did. And over the 4 years that we ran that project, there was one unplanned downtime.
I'm just really glad you talked about hospital examples and other things and not just me, because I think about like digital twin and like all the things that are going to happen there. Like my wife's like, lose 15 pounds. You know, we're supposed to go to dinner here in a few minutes. I'm like, what am I going to have for dinner? So the point is like,
You can run a simulation.
I can run a simulation and it's not going to look good. Speaking of, so, you know, you want to keep going. Okay, Andreas, please.
So quick question. Do you guys have models and platforms? Are you running this in Amazon, in Microsoft, and I'm paying for the time, or is this in prem? First question.
Okay, let's answer that one. So why don't the two of you start? We'll come over here.
Sure. So we adopt to what the customer wants, but more often than not, we work with cloud hosting platforms like Amazon Web Services.
I can put it in my data center, or I can host it.
Yes, you can, and then we have SaaS capabilities as needed.
For you guys,
Same sort of a thing. We use Amazon. We use Azure. We develop our own we do a lot of work in the cyber security 3-letter agencies areas, and so we build our own. And one healthcare client we had required that it be a local solution, and we had to work with Microsoft to figure out a reasonable way to allow that to happen.
Yeah, and I mean, I'm sure in international, that's even more urgent, right? Given some of the rules in Europe and around the world.
Architected from the ground up to be fully containerized, can run in public cloud, private cloud, on-prem, and a virtual machine and a server rack, and actually be installed on a tablet if you have a team of people that want to jump out of an airplane for some reason. The only impact is scalability of data content. You're not going to host a global digital twin on your laptop today with any sort of scalability. But if you're fighting a forest fire, maybe you can. In terms of licensing, we do everything from full OEM to platform as a service. It's module. What APIs are you getting for the data injection, and what are you using it for?
So the last two guys are users. One is a research user, and the other one is a pro. So do you build your own data twin, or do you host it in-house, or do you go out?
Yeah, so the question is for Joel and for Professor. Do you roll your own, or do you and I don't mean that. I mean roll, like, sorry. Bad metaphor. It's going to get extrapolated the wrong way. Cut that on the video. Do you make your own do you build it out yourself and roll it on-prem, or do you say, hey, we're going to go to the cloud? Like, how do you think about that?
As a corporation for Samsung, we do everything on prem because we can't afford data to be leaked. So yeah, everything in-house. We could use service providers for the software, but it's all running in-house. Zero out, especially when it comes to video or photo content. That's very sensitive.
For those of us that have sold to Samsung, we're very well aware.
Yep,
Okay.
absolutely. And then as a private, a paddleboard logistics stuff, we run our own servers actually.
Oh, cool.
It was the lowest cost.
Okay.
Approach, I think so. Yeah,
cool.
And our application is basically all in-house. We save everything in-house.
Right. Interesting. Right.
Good.
So another quick question.
Go ahead.
The data sets. So clearly you can get data from Google or maybe Every or some of the GPS guys, but do you buy the data? Do you rent the data? How does that work?
Okay, so the question was about data economics and sources and whether they're third party, first party. And so Every, GIS, what other sources of data. And so what is your business model? Do you buy it? Do you rent it? Do you license it? How does that work?
So to build the initial digital twin, that data most often comes from the city or the entity. When it comes to the simulation side, that data is not always available. So we'll either subcontract someone to collect that data, or we'll purchase that data if it's available on the open market. And then wherever third-party data is available, census data, kind of stuff, that you can get that readily. But where it's not available, you have to purchase it or subcontract to collect it.
Great. David?
Yeah, it's a real mixed bag depending on what kind of project it is. For some private clients, the only data you're looking for is data that has to come out of their system. So there's nowhere to buy that. They either have to collect it or you have to put systems in place to collect it. But we also collect our own geospatial data. We have I don't know, 4 or 5 pilots who fly geodomes, and we'll do our own geomapping if we need to do that. We also have relationship with streetlight data, so that's data that we can purchase. So it really depends a lot on the scope of the project and what kind of data you need, whether you can collect it yourself or the client needs to collect it because it's secure and confidential, or whether it's a public source thing where you can get from cities or other sources. So it's a real mix.
Right. Roger? I think we know, but
There's the hour.
yeah.
Try to be succinct. Our global geospatial data set is, we have licensed entities that we pull that from. Contractually, they update that once a quarter. So we're guaranteed that at most, the baseline geodata that we work with is fresh within a 2-3 month window of time. Regionally, we can work with either data brought to the table by the customer or data that we can source from other entities, because there are entities that do potentially more regular data flow that can come in. The way I prefer to position any content at this stage is that there's a set of vendors that I work with that have supplied data, set of customers that come in to utilize my digital twin. They can choose what data sets from what vendors they want to work with. If you want to see where all the fiber optic cable drops are, in the city of Austin, there's probably a vendor that can tell that to you. If they're in my system already, it's a check the box, and that content automatically populates your digital twin view of Austin, for example. So it streamlines the whole process of connecting the dots between pile of data and customer. And then that relationship from a customer creates that marketplace, and then the entities that, if they guarantee they keep that data up to date on a daily basis or a quarterly basis, that's that vendor, that customer relationship that's just happening within the context of my digital twin for the area.
Yeah,
essentially
bundling. Yeah.
Well, we actually utilize concepts of channels of content where you create, content that's injected and you can organize the different channels, and there may be overlaps in the content by channels. But if you subscribe to a channel of content, for example, you get that content coming into your digital twin. It could be static or it could be dynamically flowing in. It just depends on what the data is and where it comes from.
So it's only matter of time before we're over the top on that, right?
Yeah. So, quick question. Anybody thinking about taking all your creations and having the digitalization of that data into libraries and using NFTs to tokenize each element? So, I want the density, I want this much density of the data on this street.
That's
on the other streets, and I want this, and I pay 10 cents for this, 10 cents for that. Is that where it's heading?
So the question is, do you see a future, panelists, on the tokenization, NFT model for twin data and relevant models?
I'll take this real quick. Any object in our digital twin can be hooked up to a blockchain. So you have full recording of that content if you so desire. And you could stomach the overhead of 1 million objects all hooked up to a digital twin, blockchain. An example that may be somewhat unique from a digital twin perspective. We're actually involved in a project of digital twinning portions of, probably can't name the place, but it involves a casino and it involves a large city, and it involves well-known media celebrities that are involved in both the city and the casino. And they have a very strong desire to protect their brand as it appears within the digital twin in all those areas. So being able to know, because if you open up a digital twin for general access and I can put my own content in, for example, then what's stopping me from putting in a Nike logo on something? So being able to track and verify that what you see content wise can trace back to the actual originating source that you expect it to come from is critical. And so that's part of what we have to do in terms of maintaining is maintaining control of your data. So you know who's seeing it, who's using it, who's accessing it, and keeping control of that versus, me giving you a file and then telling you can't use that file for anything, actually maintaining control of that, but then having the auditing capability of verifying, yes, this content is coming from this designated kind of certified source.
I always tell my wife whatever happened in Vegas, really happened, I guess. I don't know. Yeah, it really happened, or it happened in Vegas. I don't know. I think what you're saying is we can choose now.
Any other comments on that?
That's what you're saying. Yeah.
Very specifically outside of
Yeah.
what we're working at Samsung and more of like semiconductor supply chain and parts consumption. I think the industry is actually going more smart consumables, which is interesting. Think about a filter with its own pressure gauge, right? So that's going to have its own digital twin. And so from cradle to grave, we're going to be watching how this is going. Like, okay, that batch was a little crappy. And so the NFT or like the digitalization of that ID, and maybe there's a whole supply chains inside that. I think that's very intriguing. And that was actually something that last semi standards, which is kind of like ASTM for semiconductor parts, was talking about that. How do we share that? But also making sure that the wrong people are not getting it. Yeah, competitors when it comes to our case. But I think that's very important, especially as your consumables are getting smarter.
Absolutely. Yeah. Any comments with this?
Just, these are all great business examples. What can you do for my financial portfolio?
Question is, these are great business examples. What can you do for my financial portfolio? I don't know if we're supposed to answer that question, but it's a great question.
Come see me after.
Yeah. Yeah.
Great. Any other questions?
Can I ask you something?
Yes.
So you are all tracking things, manufacturers, people, box, objects. But I'm interested in if you had any experience with the infrastructure that provides that. If I want to provide a digital twin of the communications infrastructure, of the network infrastructure, and so on top of that, I want to have a digital twin of my network infrastructure, my communications infrastructure. I'm gonna grab more bandwidth from that sampling infrastructure. So, do you have an experience with that, and what's the state of the art on that for the industry?
I'll repeat the question best I can. Here we go. So the question is about being able to have a digital twin for networking infrastructure, communications infrastructure, and to the extent that because I/O is about one of the bottlenecks that Roger pointed out, and how can you what else can you layer on top of that? I didn't. Oh, what's going on inside of the network as a digital twin? Almost like network simulation. Yeah, right. Okay, and reacting to that network latency or pressure, congestion, or whatever. Does anybody have any experience with network?
Yeah,
in
George
relation to that?
pounce on that one.
George. Okay.
So yes, there are multiple flavors of digital twins. It's a term in the industry now called network digital twin. So you take if you're talking about like a mobile operator, AT&T or T-Mobile, Verizon, you can faithfully represent their network in a digital twin world. Okay, so there's always I call it the as-built model. So you get all the information of where the towers are, what the heights of the antennas, what the output power is, all that kind of stuff. So you can show that. You can show the initial simulations of propagation. You can take crowdsourced data and display that. So there's a lot of aspects that you can readily display. Then there's the live aspect of it. And again, we're an ingester of data. So whatever data we can get from the mobile operator, we can do things with that. We can cross correlate it with other things. There's a service assurance aspect to that as well. So it kind of depends on what data we can get from the operator, and operators are kind of squirrely about sharing their data in general. But I think the answer is yes, it's possible to do. And Roger, I'm sure you can elaborate on that as well.
Yes, from EDX point of view, we position ourselves at this point as a platform, but anyone that builds on this platform is essentially delivering a solution to market for some targeted purpose. And the idea is that the platform enables them to do that quickly, easy, efficiently, blah, blah, blah. From a solution point of view, tracking the physical infrastructure, having monitoring capabilities to monitor activity across that infrastructure, whether it be a separate IoT network or whether it's telecommunications network, and you've got network management capabilities you can pull, to source current configuration of equipment or what's the current number of users are connected, that sort of thing. That information flow comes in, so you have your physical network then totally overlaid with all the other operational characteristics of the network. And then the logical next step from that is to, okay, what can I do to simulate this? I'm tracking everything. I can show when things go red on the map, but can I actually then do simulations as far as replacing this box with a new box? And the answer is yes. The framework is there to be able to do that. In EDX's case, in George's case, we have experience doing that for wireless telecommunication systems. We have some experience doing that with electrical utility grid and that sort of environment. Because again, as you slide the time bar forward, I replace this thing. Can I have a simulation of this part or this device that I'm inserting or replacing additional equipment with that device? So since I have a digital twin of a new part or new element I'm introducing that has characteristics associated with it that I can simulate, and can I plug that into historical data flow across the network and see what happens? That's a direct application of everything the digital twin brings to the table and building up to the ability of doing that, the ability of looking forward, looking at what I should do or what I can do to improve the current state of affairs. There's the larger the customer, there's continual thrash of equipment being swapped out, being replaced, being upgraded. There's a longer term of, I'm transitioning from 4G to 5G to 6G and beyond. Those are all things that a digital twin is ideally positioned to be able to analyze, because it can capture all the relevant information, can capture all the historical, the way users are accessing and using the system up to this point in time, or the way the system has behaved at this point in time, and then give you a really nice starting point for being able to say, okay, what happens if I do this? Because you can do that virtually versus the actually doing it and then, that didn't work. Let's do something else.
I was gonna have one real
Yeah,
quick
go ahead,
there.
Joel. Yep.
So I have Google Nest cameras in my house. I don't know if you ever, the facial recognition stuff, really cool. I thought it was gonna be awesome. But if I was gonna start with the question saying, can I make a digital twin of who is going through my house? The answer is no, because if I show up, my camera says my brother. Any person who's over the age of 65 is always my father-in-law. But what I can do is I could tell you, if you start with the right question, like, do I really want to see if people are there? I could probably do gender. So I think it really comes down to, can you trust your sensor, and what can you trust your sensor with? And then you can build off of that.
Yeah, very interesting. Well, thank you to all the panelists. Thank you everyone for attending. I have one last thing, which is, yeah, thank you very much. So Einstein repeatedly said, coincidence is where God lives. So I think digital twin is your neighbor. All right. And with that, thank you very much. All right.